Okay, so we're going to solve this problem, and I'm going to set up the Lagrangian. Lxy equals x squared plus y squared minus lambda x plus 2y minus 4, okay, plus mu xx plus mu yy. Okay. Now, before I solve this problem, can you tell me what is the solution to this problem? I mean, you have already done this problem or these kind of problems earlier. So, can you tell me what is the solution to this problem? Yes, 40. That's right. Okay. Now, can you tell me, is this a convex function or a concave function, x squared plus y squared? Convex. Is this quasi-concave or quasi-convex or both? Quasi-convex. Okay. Great. Great. Okay. Okay. So let's solve this. Okay. So let's solve this problem. So we already know that the solution is 40. Okay. But we'll just see, how to use KT method to solve it. And notice that Lagrangian is not concave. Okay. So I mean, the Lagrangian conditions are necessary conditions, and so it's not. I mean, there's no guarantee that every solution will be the solution to the optimization problem. Okay. So let's see. I mean, but because they are necessary conditions, so we know that at least one of them will be the solution to the optimization problem. So let's solve it. Okay. So let's first write the Kuhn-Tucker conditions. So del L by del X is 2x, okay, minus lambda, okay, plus mu x equal to 0. Okay. The next is del L by del Y, which is equal to 2y minus 2 lambda plus mu y equal to 0. Okay. The next is del L by, well, the next is basically the constraints. Okay. So lambda is non-negative. Okay. X plus 2y is less than or equal to 4. Okay. And then we also have this lambda times x plus 2y minus 4 equal to 0. Okay. And then you also have this, that mu x is non-negative. Okay. X is non-negative. Okay. And then mu x times x is 0. Okay. Mu x times x is 0. And then similarly for y. Mu y is non-negative. Y is non-negative. And mu y times y is 0. Okay. So let's solve the system. Okay. Again, what I'm going to do is I'm going to divide this into 8 cases. So first case is x plus 2y less than 4. So basically, I'm going to just check, 4 cases at the same time. When x plus 2y is less than 4, then what happens? Okay. So when x plus 2y is less than 4, then I know that lambda is 0. Okay. Fine. Because of this condition. Yes. Okay. Okay, so let's see. Okay, so this gives you mu x and mu y both will be equal to, basically mu x will be minus 2x and mu y will be minus 2y, right? Are we going to get this? Yes. Now we know that x and y are non-negative. Okay, and we also know mu x and mu y are non-negative. This gives you what? This gives you that x and y must be 0 and mu x and mu y must also be 0. Okay, so we are going to get this. Mu x is equal to 0, mu y is equal to 0, x is equal to 0, and y is equal to 0. Is that clear? Yes or no? Is this clear to everyone? Now let's quickly check, if this solves this system or not. Left hand side is 0, right hand side is 0, left hand side is 0, right hand side is 0. Lambda is non-negative, mu x is non-negative, mu y is non-negative, this is non-negative, this is non-negative, this is satisfied, this is 0, this is 0, this is 0. So this is a solution. Okay, this is a solution to this system of KT conditions. Okay, so we have one solution, which is x, y, mu x, mu y, lambda, all of them are 0. Okay, this is one solution to the KT conditions. Is that fine? Have you understood this? Okay, fine. So we have already taken care of this possibility, x plus 2y less than 4. Okay, so now we are just left with 4 cases, which is x plus 2y equal to 4. Okay, so x plus 2y equal to 4. There are 4 cases. Okay, case 1 is x is 0, y is 0 is ruled out, because you cannot have consistency with x plus 2y equal to 4. So we are just left with actually 3 cases. One is x is 4, y is 0. Okay, and then you have x is 0, y is 2. Okay, and finally, you have x and y both are positive. Okay. Okay, so let me evaluate this case first. Both x and y are positive. If both x and y are positive, then mu x is 0, mu y is 0. Okay, and if mu x and mu y are 0, then lambda equals 2x, and lambda also equals y. Okay, so now what you can do is, we also know that x plus 2y equals 4, so we can just substitute this because 2x equals y, so we can substitute it here and we can solve for x and y. Okay, so what are we going to get? Y is 2x and lambda is 2x. So if you put 2x here, you're going to get 4x plus x, 5x. So x is equal to 4 by 5. Okay, x is 4 by 5, and y is 2 times x, so y is 8 by 5. Okay, and then the corresponding value of lambda will be also 8 by 5. Okay, now you can easily check that this is also the solution to the KT conditions. Okay, so solution 2. Okay, x is 4 by 5. Okay, y is 8 by 5. Okay, mu x is 0, mu y is 0, and then lambda is 8 by 5. Is that fine? Is that okay? Okay, now let's talk about solution. Let's just consider this case. Okay, so x is 0, y is 2. Okay, so since y is 2, so mu y is 0, and since mu y is 0, lambda is y. Okay, so lambda is also 2, right? Because lambda is y, so and y is 2, so lambda is also 2, right? Okay, now we put lambda equal to 2 over here. Okay, and x is 0, so that's going to give you mu x equal to 2. Okay, so that's the third solution to the KT conditions. Okay, so we are going to get x is 0, y is 2, mu x is 2, mu y is 0, and then lambda is 2. Okay, fine. And then finally, let's just do this one as well. Okay, so x is 4, that means mu x is 0. Okay, so if mu x is 0, then lambda is 2x, and x is 4, so lambda is 8. Okay, and since lambda is 8, so we are going to put 8 here. Okay, and y is 0, so mu y is 16. Just check, is this correct? Okay, so we have the fourth solution. Okay, solution 4 to the KD conditions. Okay, which is x is 4, y is 0, mu x is 0, mu y is 16, and lambda is 8. Okay, now because these are necessary conditions, so one of them must be the solution to the optimization problem as well. So all that you have to do is just plug in the value of the objective, plug in the value of x and y in the objective and compare them. Okay, so let's just do that. Okay, 4 0, the value of the objective is 16. Okay, 0 0, it's 0. 4 by 5, 8 by 5, it's 16 by 25 plus 64 by 25, so 80 by 25. Okay, and then finally this is 4. You can see that this is the highest satisfaction level among all these 4 points. So the solution is 4 0. Okay, which is exactly what we got when we use the graphical or any of the other approaches.